क्या आप आईएएस की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेनड्राइव कोर्स के साथ आप आईएएस की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com।
Hello everyone, welcome to StudyIQ. So we will continue our discussion. This is your ninth session, right? So far we have completed almost all the important concepts related to straight lines, right? We started with general equation of straight lines, and then we have seen various forms, and then we have seen various conversion techniques. Okay, we have seen how to convert one to the other form. Then we have seen various other concepts like distance between a straight line and a point. Okay, and we have seen application of that in case of a circle, like that we have seen, right? Then we have seen distance between two parallel lines, and then we have seen the application of that also. So let's continue our discussion. In this session, what we are going to do is we'll try to understand what are parallel lines. In fact, I gave you a glimpse of parallel lines in the previous session only, and we will also try to understand what are perpendicular lines and how they are related. Then after that, we'll try to see how you are going to transform the coordinates, okay, and rotation of axis. All those things is what we are going to see in this session. So let me start off with parallel lines. Okay, so I'm going to discuss with you a family of parallel lines. So once we develop an understanding, we are going to understand it completely as family of parallel lines. That means this is going to be applicable for all parallel lines. Okay, so let me start with that. The topic is lines parallel to a given line. Okay, so you have a given line like this. So what do you mean by lines parallel to given line? I can say this is a line parallel to given line provided this distance is equal, right? And slope will be same. That we already understood. Slope will be same means minus a by b has to be the same, right? That means a, b have to be same, and what will vary is the constant part, right? So this will be another straight line. So when you take it is not a, b will be same, a by b minus a by b will have to be same, right? So this distance will anyway same throughout. Okay, again if you take this is a parallel line. If this distance throughout is same and the slope is same, right? Similarly, you can see parallel lines like this also. So all these are parallel lines to this particular line which is given. So if this is your line which is given, ax plus by plus c equal to 0, in all these cases the slopes are equal. In all these lines slopes are equal, and that's what we have already understood, right? So let's try to derive an understanding for family of parallel lines. Now the given line is this, and the equation of given line is ax plus by plus c equal to 0. So what will be the slope of the given line? Slope of the given line is minus a by b, right? Minus a by b. Okay, now if you consider this particular line, which is parallel to the given line, so these two lines are parallel means slopes are equal. Okay, so let's suppose this is your L1 line and this is your line L. Okay, so this is your L and this is your L1. So L and L1 have the same slope. Okay, so L1 is also having slope minus a by b. Okay, that is the slope of L1. So L is having minus a by b, and since these two are parallel, L1 is also having the same slope. Now once you know the slope, okay, can you find the straight line? Once you know the slope and the intercept, okay, and let the intercept be C1. Okay, y-intercept be C1. Okay, so here this is C. Okay, here we are going to talk of C1 as the y-intercept. Can you find it? See, y equal to mx plus c. We know this is the equation of a straight line. So y equal to m is the slope which is given as minus a by b. So minus a by b x plus c1, because c1 is the y-intercept. Okay, so and based on slope intercept form, slope y-intercept form, we are able to write like this. Now you can take this b to this side. So what will happen? By equal to minus ax plus bc1, because b is the denominator. We'll take LCM here and we'll take that b here. Okay, so see, ultimately this become minus ax plus bc1 by b when you try to take LCM, and then this b is going to the other side, so by. Now what you can do, you can write like this: ax plus by minus bc1 equal to 0. Okay, so this is what you get as the equation, ax and by. That is part of general form. Now bc1, what you can do is you can substitute this as ax plus by plus lambda equal to 0. Now it looks like the previous general equation that we have started off with, right? Ax plus by plus c equal to 0, but c here is lambda. So c is equal to lambda. Okay, and what is lambda? Lambda is nothing but bc1. Okay, what is B? B is this coefficient of this y, and C1 is the y-intercept. Okay, so that will give you C, or that will give you lambda. Okay, so this is the equation which represent family of all straight lines. Now what you need to do is, if you need to get another parallel line, this will remain the same. Ax by will remain the same, there is no change. What you can do is, you can vary this lambda. So for another lambda value, which is lambda 1, you will get another parallel line. Keeping this as same, for lambda 2 you will get another parallel line. For lambda 3 you will get another parallel line, which are parallel to the given line which is given, right? So ax plus by plus c equal to 0 is given. So if you take this, ax plus by plus lambda equal to 0 represent family of straight lines, where lambda you can vary, you will get all the parallel lines, and lambda is given as bc1, okay, or minus bc1, right? Minus bc1. So I hope you understood. So this represent the parallel lines. So ax plus by plus lambda equal to 0 represent all lines or family of straight lines which are parallel to ax plus by plus c equal to 0. Now what is lambda? Lambda equal to minus bc1. So for different y-intercept, you will get different parallel lines. So how the lines are different now? Lines are different based on the difference in C1. So here it is C. So if for C2 you will get another line which is parallel to the given line. For C3 you will get another line. For C4 you will get another line. But this part is the same. And the slope will be same, that is minus A by B. And we actually started from there only, okay. So this represents family of all straight lines. Same is the case with perpendicular lines. So if I am giving you this line, okay. So this is my given line. So this is a line which is perpendicular to that line, okay. So this is perpendicular, or I can say this is another line which is perpendicular, this is another line which is perpendicular, this is another line which is perpendicular, this is another line which is perpendicular. So if you remember, there was a condition, right? So let's suppose I need to say two lines as perpendicular, okay. So line L and L1 are perpendicular if and only if the slope of L and slope of L2, when you multiply, you should get minus 1. We have done with this concept already, okay. So here, let's suppose the given line is ax plus by plus c equal to 0. That's your given line, okay. Now what is the slope here? Slope here is minus a by b. Now what I need to do is, I need to take a line which is perpendicular. So let's take this line which is perpendicular, and let's try to find out the equation of that, and based on that we'll generalize it, okay. So ax plus by plus c equal to 0 is a given line. The line which is perpendicular to that line, we know one condition, that the slopes of this two, if you multiply, you'll get minus 1. So slope of the given line is minus a by b into slope of L1. Okay, slope of L1, what you'll get? You'll get minus 1. So clearly you can get slope of L1 as what? B divided by a, right? Because a by b and b by a will give you 1, and since there is minus here, automatically minus will come in the answer, okay? So b by a. So what is this? The concept is, what is this? Is slope of given line, slope of the perpendicular line. When you multiply, it has to be minus 1. Based on that, we got the slope of the perpendicular line. Now once you know the slope, okay, and then can you get the equation if you know the y-intercept also? So the equation is y equal to, okay, mx plus c, where m is the slope, c is the y-intercept. Now let's assume that the y-intercept is c2. Let's assume that the y-intercept is c2, and slope we understood that b by a. So you'll get b by a x plus c2 equal to y. So this is the equation. Now you can take a as the LCM. So a will go to c2, then a will come to ay, this y. So it will become ay equal to bx plus ac2, right? Because this a has gone here, then a become the common denominator. That a we are taking to the left hand side, so you'll get expression like this. So once you get like this, what you can do? You can rearrange it as bx minus ay plus ac2 equal to 0. Okay, so or you can replace ac2 as lambda bx minus ay plus lambda equal to 0. So what is lambda? Lambda equal to ac2. Earlier in case of parallel line, what was lambda? Lambda was bc1, right? C1 was the y-intercept there, here C2 was the y-intercept. There was minus bc1, here ac2 is this. So based on this variation, you will get perpendicular lines, provided there is a change here also. The coefficients I changed, and I am putting a minus symbol here. So once you come across perpendicular lines, there is a significant change. See, here there is a change. Coefficients of x and y changed, interchanged, and you are putting a minus sign here. Okay, so your equation of given line was ax plus by plus c equal to 0. The perpendicular line, or the equation which represents family of perpendicular lines, I can write it as change the coefficient first. So bx and ay. Put minus symbol in between, minus, because I need to get minus 1 as a slope when you multiply, okay? Plus, instead of c, you can put lambda equal to 0. This represents family of all straight lines. So the changes here, coefficient you can see the change, and the sign you can see the change. Plus, here also you can see the change. Y-intercept changes, this will change. Okay, so quickly, in case of parallel lines, given line is ax plus by plus c equal to 0. In case of parallel line, the equation which represent the family of parallel lines are ax plus by plus lambda equal to 0, where lambda equal to minus bc1, where c1 is the y-intercept. In case of perpendicular line, the given line is ax plus by plus c equal to 0. Okay, what you need to do is change the coefficients of x and y, then put minus sign in between. Bx minus ay plus lambda equal to 0. Here lambda is ac2, where c2 is the y-intercept. Okay, I just changed it. That's it. Okay, so this is what the key takeaway from this. So this represents family of all parallel lines, and this represents family of all perpendicular line to the given line ax plus by plus c equal to 0, which is a general expression of a straight line. I hope this is understood completely. Okay, let's move on to the next topic. The next topic is transformation of axis. Okay, transformation of axis. Very important topic, you'll get question. Transformation of axis and rotation of axis, out of which rotation of axis is more important. Okay, but let's try to understand transformation of axis first. That is very easy actually. See, let's take in my Euclidean plane, let's take, this is your x and this is your y. Okay, so xy axis, let me take a point somewhere here. So this is my point a, x comma y. Okay, or I can write it as x1 y1. So this is my point a, x comma y. Now what I'm going to do is I'm changing the axis. That means I'm actually shifting the origin. Here my origin here is 0 0, right? Origin is 0 0. What I'm going to do is I'm creating another axis or another Euclidean plane, or I am changing the origin like this. So I can show like this. So this is my new y, I am marking it as capital Y, and this is my new x, I am writing it as capital X. Okay, so if you look at the first case, this is your x distance. Okay, this is your x distance and this is your y distance. Okay, now if you look at the same point now, again here, this represent a, capital X, capital Y. So a, that is a point. Okay, representation of that point in the new system is capital XY, old system is small xy. That is understood, right? Okay, now what is this distance? If this distance is h, if this distance is h, and if this distance is k, okay, if this distance is k, that means the new origin is going to be h comma k. Okay, I can mark it as p of h comma k. So if this distance is h and this distance is k, this point is the new origin. So that point, the origin is h comma k. Okay, this is the old origin, this is the new origin. This point is the same point that I am taking, but that point is different with respect to two axes, right? In the first case, it was x comma y coordinates, small x, small y. Okay, that is in the old system. In the new system, it is capital X and Y. Definitely there will be a variation, right? So what we need to do is, we need to understand what is this capital X and capital Y, or how will you get that capital X and capital Y, or if capital X and capital Y is given, how will you get the small x and small y. Okay, so the very same point in the new axis is given, can you find the old coordinates, or if all coordinates are given, can you find the new coordinates? That's the only thing. Okay, so this is actually very easy. See, the capital X, if you need to know, that will be x minus h. Why x minus h? Because this distance you can clearly see, this distance is x, okay, and this much is h. What we are looking for? We are looking for only this much. We are looking for only this much. Total is x, this much is h, so x minus h is your x. Similarly, what is your y? You can clearly see, total, this is y, okay, this is y, and this much is your k. In the new system, I am looking for this much only, right? This much only. The origin is this, so I am looking for this much only for my capital Y. So clearly that is y minus k, right? So y equal to y minus k, y minus k. Now from this you can get, so if the new origin is given, and old coordinates are given, you can find the new coordinate like this. Okay, so the question is like this, you have originally the points are 0, 0, and for this case you have let's say x comma y. There's a point. Okay, I need to change the axis, so I am making new case. So with respect to the new, what is this point? So you will get, if you know this distance and if you know this distance, you'll be getting this origin. So the origin will be given here, h comma k. So you clearly understand the new x coordinate will be x minus h, new y coordinate will be y minus k. That's it. Very simple. Now in the new system, if the new system is given, that means this is given, okay, like this much only. So I am saying this is a system h comma k, okay, and this point is given, that is x and y. So can I find the coordinates in the normal system, that is 0 comma 0, if 0 comma 0 is the origin? Obviously you can. How will you find it? X will be x plus h. Why? Because you can clearly see this is your x, capital X, and this much is your h, and this total is your x. So small x, if you need to find with respect to origin 0, 0, that is x, that is a coordinate in the new system, plus the x distance from this case, okay, from here to here, this from origin to the new x, from the new origin, what is the distance? So take that, okay. So x plus h, similarly y is equal to y plus k. So this two you need to remember. Anyway, practically when you are solving the question, you'll automatically get it. But the point is, this is how you need to convert, and you will get questions based on this. Similarly, in case of rotation of axis, what do you mean by rotation of axis? See, it's like this. This is your x-axis and this is your y-axis. So rotation of axis by 45 degree. What do you mean by that? I will rotate x by 45 degrees, so I'll get my new x-axis like this, and I'll rotate my y as 45 degrees, so y will become this. Okay, so my new Euclidean plane will look like this. This will be gone, this will be gone, this will be gone, this will be gone. So this is how I'll rotate the axis. Now when you're rotating axis, see, like this, see, you can clearly see when you're rotating 45 degree clockwise direction, you can see this is going to be minus pi by 4, right? This angle is minus pi by 4. So that's how you need to understand here. Now what you will get is, see, let's suppose there is a point somewhere here. Okay, let's suppose there is a point. Let's take that point somewhere here. Okay, so this is the original case P of xy. Let's take the very same point. Now what will happen with this point when you rotate the axis? That is what we need to understand. Okay, so what will be the new point? Okay, so if you mark the new one as x and y, there is a table. If you remember that table, then that conversion is going to be very easy. You can just look into the table and you can get the answer. So the table is like this. This is capital X, this is capital Y. That is a new case, small x, small y. So cos theta minus sin theta, cos theta. Okay, so if you need to find the old coordinate, okay, x is equal to, see this, x cos theta minus y sin theta. I am looking for x, so I take this, okay, and I take both x and y. So x cos theta, y sin theta. So x cos theta minus y sin theta. So obviously if you need y, that is going to be x sin theta plus y cos theta, right? Similarly, if you need x, that is a new one, you go like this, x cos theta, y sin theta. Okay, so x is going to be x cos theta plus y sin theta. Similarly, if you need y, go like this, x minus x sin theta, y cos theta. So y equal to minus x sin theta plus y cos theta. So this will give you the new coordinates and old coordinates. So x and y is the new coordinate, this x and y is the old coordinate. What is theta? Theta is the angle in which you are shifting, you are rotating. Okay, so if you are rotating in clockwise direction, it will become minus. If you are rotating in the anti-clockwise direction, it will become positive. And based on the condition of the question, you can solve the question, and it will be very easy if you remember this table. If you want, I'll give you one question. Okay, so keep this in mind. X is equal to x plus h, y equal to y plus k. This is capital Y. So this is the old one. X is equal to x minus h, y equal to y minus k. This is the new one. So this one, that is a transformation of axis. This one, that is a rotation of axis. Keep it in a table. Remember this. That will help you in solving the questions faster. Don't try to get these values at that time, okay? So that is not worth, okay? So you can just remember either this table or this. Remembering this table is easy, right? So if you need to get this capital X, then easy, like this. So capital Y, just go like this. If you need to get the small x, go like this. Small y, go like this. Okay. So take a question now. I need to find the coordinates of the point 2, 3. Okay. So I am giving you point 2, 3. First case, origin is shifted to 1, 1. I am shifting origin to 1, 1. So my new origin is this. I'll show you in diagram so that you'll understand. Second, what I need to do is, axis is rotated by an angle pi by 4 anti-clockwise. So when I rotate anti-clockwise, that is plus pi by 4. When you rotate clockwise, that is minus pi by 4. I have discussed already. Okay. So two cases. See what is 2, 3? That is in the normal case, right? In my Euclidean plane, if you take x and y, 2, 3 means let's suppose this is 2. Let's suppose this is 3. So I am talking of this point, that is 2, 3. So this is your 2, 3. That is in this case origin is at 0, 0. What I am doing then, I am shifting my origin to 1, 1. So this is my new origin, that is 1, 1. And with respect to this, what is this case? So I need to find capital X and capital Y, right? So small x and small y is known to you. So this distance is 1, this distance is also 1. So that is nothing but 2 minus 1. So x is going to be small x minus 1. So x minus 1, that is 2 minus 1, that is 1. And y equal to small y minus 1, that is 3 minus 1, that is 3 minus 1, that is 2. So I got these points, right? 1, 2. In the new system, that is 1, 2. Now, if you are rotating the axis in an anti-clockwise, that means it will go like this. Anti-clockwise means x will come here, okay? Y will go there, like this. I hope you understood, right? So that is making an angle pi by 4, okay? Then what is your answer? I need to find, see, small x and small y is given. So if small x and small y is given, I need to find capital X and capital Y. So what is x? X is equal to x cos theta plus y sin theta. Y equal to minus x sin theta plus y cos theta, right? Now theta we know, since you are rotating anti-clockwise, theta is pi by 4. So you can write here x is equal to 2, x is equal to 2, y equal to 3, theta equal to pi by 4. Just substitute, you'll get x coordinate. So x is equal to 2 cos pi by 4 plus 3 sin pi by 4, okay, which is equal to 2. Then divided by root 2, cos pi by 4 is 1 by root 2 plus 3 by root 2, so you'll get 5 by root 2. That's your new x coordinate, okay. Y equal to minus 2 sin pi by 4, I can directly write it as minus 2 root 2 plus 3 by root 2, okay, just substituting here. So you will get it as 1 by root 2, right? Minus 2 plus 3, that is 1 by root 2. So what are your new coordinates? X comma y. X comma y is 5 by root 2, 1 by root 2. Okay, so see, 2 comma 3 are the points which is given to you. In the first case, okay, in the first case, like this, if this is your origin, 2 comma 3 is given to you. I am shifting this to a new case, that is origin is 1, 1. Then the very same point will be 1 comma 2. The very same point in the new system will be 1 comma 2. Similarly, if you are rotating your axis, what does that mean? X will go like this and y will come like this. This is your x and this is your y. And the very same point will be changed like this. 5 by root 2 and 1 by root 2. Okay. So instead of 2, 3, it will be 5 by root 2. X coordinate will be 5 by root 2. Y will be 1 by root 2. And that's what you need to understand, and that's how you need to interpret. So I hope this is clear for you. So what we have discussed is in this session, parallel lines, family of parallel lines, family of perpendicular lines. I told you here slopes are equal. Here when you multiply the slopes, you'll get minus 1. Based on that parallel lines, we got ax plus by plus lambda equal to 0, represent the family of all parallel lines, where lambda equal to minus bc1. Then bx minus ay plus lambda equal to 0, where lambda equal to ac2, represent all perpendicular lines. Then we have seen transformation of axis and rotation of axis, right? So in case of transformation of axis, x is equal to x plus h, y equal to y plus k. That is the old case. New case, x is equal to x minus h, y equal to y minus k. Okay, what about rotation of axis? You just need to remember the table x, y, cos theta, sin theta, minus sin theta, cos theta. So what is your x? X is equal to x cos theta minus y sin theta. What is your y? That is the old one. Y equal to x sin theta plus cos theta. What is your capital X? That is a new one. That is equal to x cos theta plus y sin theta. What is your y? That is a new one, equal to minus x sin theta plus y cos theta. So that's it. If you have any doubt, you can get back to me. Okay, so see you guys. I hope we'll discuss more of this kinds of questions in the next session. Most probably I'll be starting with circle and we'll complete circle. Okay.
क्या आप IAS की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेन ड्राइव कोर्स के साथ आप IAS की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com।